Hello everyone, and a big thanks to the organizers for inviting me today. My name is Giacomo, and I'm a UI and UX designer at Accenture. I'm here to talk to you about my work on a design language system and to share some tips that I hope can help whoever is working on this kind of project in improving the usability of their library files. Before we start, a few words about myself. So that's me with a monkey, because why not? My career started off as a freelancer, and after years and years of collaborating with communication agencies, design studios, and whatnot, I joined Accenture in 2018. For the last couple of years, I've been part of a small team working on a very ambitious project, a design language system that could scale across several of the company's applications. So it was quite obvious from the start that the task would be pretty challenging. Our mission was to audit a portfolio of dozens of different apps to create a design system that would accommodate all of the functional and non-functional requirements of those apps, while still maintaining the company's strong visual identity and narrative. But first of all, what exactly is a design language system? Even though I'm sure that most of the audience is already quite familiar with the concept, it remains a quite broad and kind of vague domain. And depending on who you ask, everybody seems to have their own definition. These are some of my favorite ones that I stumbled upon while reading articles and listening to speeches. So Brad Frost, the first to theorize the atomic design concept, says that a DLS is the story of how an organization builds a digital product. Alla Kolmatova, the author of a great book called, wait for it, Design Systems, defines it as connected patterns and shared practices organized to serve the purpose of a product. Or again, a Bible of visual standards, typography guidelines, color palettes, and repeatable patterns used to dictate the voice and tone of a brand. And at last, my favorite of all, what brings order to chaos, which, in my opinion, really sums it up perfectly. So, no matter how you decide to define it, the general idea remains the same. A design language system is a single source of truth based on design assets, guidelines, code assets, patterns, and semantics, with the goal of improving the design process with scalability and consistency. I guess I have my definition too now, so just add that one to the list as well. The market today offers dozens, if not hundreds, of great examples of design systems built and distributed by companies of all sorts. For example, we have Material Design by Google, probably one of the most famous ones out there. Carbon by IBM, which is my personal favorite. Protocol by Mozilla. Polaris by Shopify. Airbnb Design. Baseweb by Uber, and this is just to name a few. But a design system can also live outside of the corporate world, and since I'm a huge comic book fan, I felt a strong urge to include in my speech the recent and quite awesome rebranding of the X-Men. In 2019, Marvel Comics decided to completely renew the franchise, from both a storytelling and a design standpoint. Author Jonathan Hickman, along with designer Tom Miller, drove the look and feel of the series through the roof, in a quite different direction to what comics usually do. The new brand identity relies on, and you probably guessed it, a design system. Its minimalist aesthetics are heavily inspired by Swiss design, and in my opinion, it works really, really well, scaling perfectly across the many titles connected to the X-Men roster. Okay, back to business now. So my main job on the design system that I've been working on in these past years is to craft and test the components in the so-called UI library. A UI library usually comes in the form of one or more design files, which we can call mother files. Designers can install these mother files as libraries to use the ready-made components and styles without having to actually open the files themselves. A mother file is usually stored in the cloud. Every time a new component is added or a change of some sort is made, it happens in that specific file, which consequentially updates all of the children files that use it. One of my tasks is also to operate as a housekeeper for those library files, which means I have to make sure they're always tidy, updated, and efficient. You see, a design library is an entity in constant evolution, and it can be a big, hot mess with hundreds, if not thousands, of symbols. So this role is of the utmost importance, or that's what I like to think at least. So this job has had me spending quite a large portion of my days working on ways to make the library more smart and more usable for both our team and the designers that will be using it for their projects. I'm sure everybody has their own tricks and techniques on how to create and maintain a library, because whatever works, right? Nonetheless, I would like to share a few tips based on my personal experience, which I hope will benefit you no matter your level of knowledge on the subject. I'm going to get a little technical, but please bear in mind that I'm referring specifically to the software that I usually work with, which is Sketch. Although a lot of what I'm about to say is just based on common sense, and it can surely be applied to other similar tools as well. Okay, let's begin. So the first tip on my list is go subatomic. A design system is a modular, scalable way of approaching design. You start from units, combine those units into bigger entities, and just keep scaling up. This concept is known as atomic design, and it borrows its terminologies from science. You start from atoms, you combine those atoms into molecules, the molecules into organisms, and so on. You get the point, right? So the atoms are the smallest building blocks for the design system. They're the smallest functional UI units, which means they cannot be broken down any further without ceasing to be somewhat functional. Some examples of atoms are buttons, inputs, and selection components, such as checkboxes and radio buttons. While struggling with ways to easily make changes to multiple elements at once, I came to realize that sometimes it actually can be useful to create components that are even smaller than the atoms. These subatomic particles are structural, non-functional components that can help gain more control over a library file and save time when having to perform major changes. To give you a practical example, I'll walk you through a common use case. So in your DLS library, you'll probably have, say, at least 4 or 5 different types of buttons. Primary, secondary, outlined, text button, destructive. Pretty much the industry standard. Let's say now that for each type of button, you want to offer a text-only variation, an icon-only variation, and a text with icon variation, with the latter available both with the icon on the left and the label on the right, and vice versa. That's 20 button types. It's likely that for each type of button, you're going to want to offer at least 4 different states: active, hovered, pressed, and disabled. So multiply that for the number of button types, and you find yourself with at least 80 symbols. And we're just considering one single size, which means that potentially your file could contain hundreds of button styles, which is pretty intense, right? Okay, imagine now that you started out with right angle buttons, sharp corners, 0 radius. Now, at some point along the line, you and your team decide that it would be cooler to round those button corners a little bit, just to give them a bit more of a friendly look and feel. With all the button containers as separate instances, you would have to individually select each of the 80 or more backgrounds and change the radius. Quite a lengthy operation, which at some point along the line might need to be repeated if a different design decision is made. The solution, that I found at least, is to create a single subatomic component, which we could call button container, for example, and use it as a background for all of your button types, variations, and states. By doing so, performing a structural modification like changing its radius will just waterfall on all of your buttons, Creating subatomic elements common to multiple components within the library is a smart way to perform bulk modifications with just one click rather than hundreds. A ripple effect across your whole DLS that will save you a lot of time and a lot of headaches. So other example of subatomic components could be fields, labels, and containers, or even modal containers, for example. Okay, so my second tip for you would be don't be sloppy. One thing to keep in mind when creating a DLS is that you need to design for two distinct audiences. The first group are the actual end users of the digital products that will be built with your design system. The second group are the product teams, so designers and developers, that will use it to build those digital products. This means that not only a design system should look good, be accessible, and offer a solid user experience, but also that it should be efficient and easy to use by the people that basically do the same job as you do. So think of your library files as the first line of defense. For it to work well, the way you group and name your symbols must be bulletproof. Let's start by the grouping. So the first thing I would suggest is to try to be smart with the way you group your symbols and avoid excessive nesting. When I talk about excessive nesting, I mean something like this. Probably setting a limit to 4 or 5 levels of nesting could be a good practice. More than that could start to become a little overwhelming for the users. Try to figure out if some levels of nesting can be avoided with workarounds. For example, if you offer a group of inputs with the helper text and a group of the same inputs without the helper text, you might want to consider just offering one group of inputs with the helper text by default and make it removable with an override. Okay, naming your symbols. So smart symbol naming can really improve a library's usability. Using numbers to give the order you want to elements in a group is a great way to decide your own hierarchy and to not be forced to stick with the alphabetical order. For example, the states of an input can be numbered in a chronological order. So 1 for default, 2 for hovered, 3 for active, 4 for filled out, 5 for error, and 6 for disabled. This will make the selection of a different state of the component much quicker and intuitive. So while being tidy is surely a good practice in any type of project, it's essential when working on a design system. A consistent and organized naming of elements in a library can be a bit of a drag, I know that, but I assure you that it always pays off. For example, all the labels in the library should be called label. All of the backgrounds, background or container. All of the fields, field. You don't need to be too creative with it. It's so easy to just lose track of naming and get a little lazy, and believe me, I know that very well. By default, Sketch will add the word copy to any element copied by dragging and holding the Alt key. It's very common to see files just full of instances and symbols called something something copy 1, something something copy 2, something something copy 1,000. I admit that sometimes I might be a little obsessive compulsive, but this kind of thing just drives me off the wall. What it also does though, is it makes life much harder for the designers that will be using your file and working with overrides to modify the symbols. In Sketch, the override panel, which is located in the so-called inspector area on the right, allows you to change certain things in a symbol without having to structurally modify it. Let's see an example. Pretend you haven't been too careful when naming the elements that make a complex symbol like a data table. The override panel will end up looking pretty messy. When you do a good job with the naming, however, the panel will look something like this, just better and easier. So if you want to get a little crazy, emojis can also be a fun and pretty efficient tool for naming layers, and they can really help the user identify elements in a group. Don't overdo it, of course. Finally, tip number 3. Set boundaries. This is a takeaway that is applicable through our lives, but also to our sketch files. We want to allow designers that use our libraries to have creative freedom, but we also want to make their work easier and ensure that they respect the rules of our DLS. Sketch has recently added a great new feature to the override function by allowing you to decide the overrides you want to enable for your components and the ones you don't. This means that when creating a new symbol, you can simply uncheck the parameters that you don't want to show in the user's panel. Say you're building a text input. This type of component is usually made of a field, a title, and a placeholder. While managing the overrides, you're going to want to allow the user to only be able to modify the input's title and the placeholder, but not the text field, because that kind of parameter is usually codified with a specific style and it shouldn't be changed. So just go on and uncheck the field. When using an instance of this symbol, the override panel will look something like this. So I know this might not seem like a really big deal right now, but imagine creating a complex component like the data table we talked about previously, with dozens of possible override parameters. The difference in usability can be huge. The practice of limiting overrides is definitely worth investing some time in. It declutters the library's usability, but it also allows you to set certain boundaries to avoid designs that don't respect your style guide. If a designer really wants to customize a symbol, can always decide to detach it anyway. Not much we can do about that. Okay, so that's it. These are the takeaways from my experience that I hope can help you improve your workflow, but especially the usability of your library files. I would like to finish with a quote by the great Emil Reuter, which I think fits well with what we talked about today. To design is to plan, to order, to relate, and to control. In short, it opposes all means of disorder and accident. Thank you so much for following.